Hi, I'm Dr. Saroja. Today I'm back with another video, that is a small introduction to chemical thermodynamics. What is chemical thermodynamics? It's a branch of physical science that deals with heat and other forms of energy and the relation between all forms of energy. It deals with transfer of energy from one form to another. It deals with heat, work and energy of a system. What is heat, work and energy of a system? Let us see in little more detail. Internal energy. What is internal energy? It is the invisible microscopic energy. It is different from macroscopic energy. It is microscopic energy due to the random motion of the atoms and molecules. The vibrational energy, rotational energy of atoms and molecules comes under this. What is heat energy? Heat energy is due to the movement of tiny particles like atoms and molecules or ions in solids, liquids and gases. It is transferred from one object to another. Heat energy is usually transferred from higher temperature to lower temperature. What is work? Work is the transfer of energy by a force acting on an object as it is displaced. This is work. These are the three important quantities in chemical thermodynamics: internal energy, heat energy and work. Now let us see some definitions of chemical thermodynamics. Let us begin with the definitions of system and surroundings. What is a thermodynamic system? Thermodynamic system is that part of the universe which is under observation. That is, whose properties we are measuring. For example, this portion of the universe is the system and this rest of the portion of the universe is the surroundings, and the system, the rest of the universe constitute the surroundings. System and surroundings together constitutes the universe. Now let us see why at all things happen in the universe. Why does anything happen at all? Why does water always flows downhill? Why does hot water cool down after some time? Why does carbon dioxide effervescence comes out from an open soda bottle? Why does a chemical reaction occur at all? All these is because of thermodynamics. Transformation of energy from one form to another results in all these processes occurring spontaneously. Laws of thermodynamics explain the occurrence of every event in nature. Let's see what are the various types of energy. Many forms of energy exist in the universe and they are basically of two types: potential energy and kinetic energy. What is potential energy? Potential energy is due to the position of an object. It is the stored energy and it is by way of position. What are the different types of potential energy? Let us see. Chemical energy. Chemical energy is stored in atoms and molecules. For example, the energy stored in coal, natural gas, petroleum, batteries and the food we eat is all chemical energy that gives us energy to do work. Mechanical energy is stored in objects by way of tension. Compressed strings, stretched rubber, etc. have mechanical energy. Nuclear energy. It is stored in the nucleus of an atom. It holds all the neutrons and protons together. What is gravitational energy? It is stored in an object's height. Higher and heavier the object, the more is the gravitational energy. Next let us see what is kinetic energy. Kinetic energy is due to the motion of the object, motion of electrons, atoms, molecules and objects. Let us see what are the various types of kinetic energy. Radiant energy. It is electromagnetic radiation, electromagnetic energy that travels in transverse waves in sine curves. Let's see what is thermal energy. Thermal energy is due to heat. It is due to the movement of atoms and molecules. What is motion energy? Motion energy is stored in moving objects. The faster the movement of the object, the more is the energy. Sound energy. It travels in longitudinal waves. When a force makes an object to vibrate, then it has sound energy. Now let us see the types of systems. What are the three types of thermodynamic systems? These are some of the definitions of thermodynamics. An open system. Open system is one which can exchange the energy and matter both with the surroundings. For example, an open cup of hot tea. When hot tea is placed in the open cup, the temperature is being given away to the surroundings. Hot tea becomes cold after some time, and if there are some mosquitoes or flies around, they can fall into tea, so it can take up matter, it can give away the matter, and that is an open system. Closed system is one which is only open to energy but not to matter. For example, this cup of tea is covered with a lid, so matter cannot come in or go out, but the heat of the tea is lost after some time, because heat always flows from higher temperature to lower temperature. So this is close to matter but open to energy. So this is called a closed system. What is an isolated system? Is one which can neither exchange energy nor matter with the surroundings. For example, hot tea is placed in a thermos flask. Then matter can neither come in nor go out, and energy also can neither come in nor go out. This is an isolated system. Because nothing can go in and come out, isolated system has constant energy. These are the three types of systems. Now let us see the simple laws of thermodynamics. The zeroth law of thermodynamics. When two systems are both in thermal equilibrium with a third system, the two initial systems are in thermal equilibrium with one another. This is the definition of zeroth law. That is, if B is in thermal equilibrium with A and C is also in thermal equilibrium with A, then B and C are also in thermal equilibrium. This is the zeroth law. B and C are in thermal equilibrium with A, then B and C are also in thermal equilibrium with one another, and their temperature is the same. Thermal equilibrium means temperature is the same. When bodies of different temperatures are in contact with one another, then the heat will flow from a body of higher temperature to a body of lower temperature in order to achieve thermal equilibrium at the same temperature. This is the principle behind thermometer. Thermometers are designed to achieve thermal equilibrium with the surroundings, and they give a quantified relative value of the temperature at this equilibrium. So this is the zeroth law of thermodynamics. Now let us see another simple law, which is the first law of thermodynamics. This we all of us experience in our real life. Total energy of the universe is constant. Energy can neither be created nor destroyed. It can be transformed from one form to another in the form of heat or work. So this is basically the definition of first law of thermodynamics. When systems are in contact, energy is allowed to flow and thermal equilibrium can be attained. For example, heat. Heat is absorbed or evolved by the systems. If heat is absorbed, it's given a positive sign, and if it is evolved, it's given a negative sign. Heat absorbed is an endothermic reaction. Heat evolved is an exothermic reaction. Change in internal energy of a system is heat absorbed minus work done. This is basically the first law of thermodynamics. Mathematical equation of first law of thermodynamics. When force is applied on a system causing displacement, then work is done on the system. When force is applied on a system causing displacement of the system, then work is done on the system. In this case, energy is added to the system and hence it's given a positive sign. Work is given a positive sign. Now let's see the negative sign of work. If a system applies force on something else causing displacement, then work is done by the system, and in that case energy leaves the system, and therefore work is given a negative sign. So these are the positive and negative signs of work and heat. And now let us see what is the mathematical expression of first law of thermodynamics. Delta E is equal to Q minus W. Delta E is the change in internal energy, that is equal to Q, heat absorbed, is given a positive sign, minus Work done by the system is given a negative sign. So heat absorbed minus work done, that balance of energy goes and adds up to the internal energy of the system. Hence, the total energy of the universe is constant. Therefore, delta E is equal to Q minus W. This is the first law of mathematical expression of first law of thermodynamics. So, apart from these two, there's another law, that is second law of thermodynamics, which deals with entropy, but this little more complicated. Therefore, that has to be done in a separate video. I will do that a little later. Now, so this is the basic introduction to chemical thermodynamics. If you like my video, please subscribe it, and if there's anything specific that I can come up with, please let me know in the comment section. Thank you so much for watching my video. Thank you.